Till now we discussed three enzymes. What is the first one? Lipases. Sir, lipases are chemically made up of what, sir? Proteins. Because lipases are also enzymes. Almost all enzymes are chemically proteins. Lipases also chemically made up of proteins. Lipases acts on lipids. Pectinases chemically made up of proteins. Acts on pectin. Proteases chemically made up of proteins, acts on proteins, right? Now listen here, this pectinases, what? Pectinases and proteases, what and what, sir? Pectinases and proteases are used for clarification. Used for which process? Clarification. Clarification of what, sir? Bottle juice. Clarification of which juice? Bottle juice. Sir, what is the meaning of clarification? Clear. See, if you get a Maaza bottle from market, in that Maaza bottle, right, the cool drink, the Maaza liquid will be very clear. It means you can't see pulp in that juice, yes or no? It means that pulp gets digested. Who is digesting that pulp in that Maaza, sir? Pectinases and proteases. It means pectinases and proteases, they are used for clarification of bottle juice. Take a homemade juice. It means the juice what we are making in the home. Compared to homemade juices, bottle juices are clear. Yes or no? Sir, who is making them clear, sir? These pectinases and proteases. Therefore, addition of pectinases and proteases makes the bottle juice clear. Therefore, compared to homemade juice, bottle juice, how it is? Bottle juice is clear, clarified. Bottle juice is clear, clarified due to addition of pectinases and proteases. Due to addition of what? Pectinases and proteases. What happens? The bottle juices gets clarified when compared to what? Homemade juice. Is it okay? Right? Therefore, this is concerned to, right, pectinases and proteases. This is concerned to pectinases and proteases. Now go for number 4. Rennet. What it is? Rennet. Fourth enzyme. Rennet. Sir, this rennet can be also called as renin. This rennet is also called as what? Renin. Sir, this rennet enzyme is used for what, sir? This rennet enzyme is used for making cheese. Used in what? Used in cheese preparation. It is used in what? Cheese preparation. Which enzyme? Rennet enzyme, also called as what? Renin. Used in which preparation? Cheese preparation. Sir, to produce this rennet enzyme commercially, we are exploiting which microorganisms, sir? We are utilizing which microorganisms, sir? This rennet extracted right from mucor. What is the fungi name? Mucar, right? And Endothea parasitica. What it is? Endothea parasitica, Mucar. These are two microorganisms which are commercially, right, which are used for commercial production of rennet. Therefore, industrial production or commercial production of right rennet is done by exploiting which microorganisms? Mucar and Endothea parasitica. Mucar and what? Endothea parasitica, right. These are some important statements concerned to, right, enzymes. We are discussing chemicals, enzymes and other bioactive molecules. We completed right, chemicals, that is organic acids and alcohol, and second one is enzymes. In enzymes we discussed about lipases, pectinases, proteases, and next one is rennet, right. Now we are going for other bioactive molecules. Other bioactive molecules. Other bioactive molecules. Other bioactive molecules. In these other bioactive molecules, we are going to discuss about right, number one, streptokinase. What is the first one? Streptokinase. Number two, second one, cyclosporin A. What is the second one? Cyclosporin A. Number three, statins or statins, right. Therefore, streptokinase, cyclosporin A, and third one is statins or statins. Go for first one. What it is? Streptokinase. Go for streptokinase. Go for streptokinase. Now listen here. This streptokinase is extracted from a microorganism by name Streptococcus. What is the organism name? Streptococcus. Sir, what is the meaning of Streptococcus? Coccus means spherical shaped bacteria, right? What is the meaning of coccus? Spherical shaped bacteria. What is the shape? Spherical. Bacteria or virus? Bacteria. Coccus, spherical shaped bacteria. What is the meaning of streptococcus, sir? A group of spherical shaped bacteria arranged linearly in a single row. Arranged how? Linearly. In how many rows? Single row. How many bacteria? A group of bacteria. What shaped bacteria? Spherical shaped bacteria. Therefore, streptococcus, a group of spherical shaped bacteria. A group of spherical shaped bacteria arranged, how they are arranged? Arranged linearly in a single row. Arranged linearly in a single row. Therefore, a group of spherical shaped bacteria arranged linearly in a single row, that is streptococcus. What it is? Streptococcus. Therefore, from this streptococcus, what? Bacteria. From what? Streptococcus bacteria, what is obtained? From streptococcus bacteria, streptokinase is obtained. Streptokinase obtained. What is obtained? Streptokinase is obtained. Is it okay? Right? Sir, this streptokinase is genetically modified. Streptokinase what? Genetically modified. Who is genetically modified? Streptokinase is genetically modified. This genetically modified streptokinase is used as a clot buster. Who is used as a clot buster? Streptokinase. Genetically modified streptokinase. Streptokinase is used as a clot buster. Sir, from where we got this streptokinase, sir? We got streptokinase from Streptococcus bacteria. Streptococcus bacteria. It means, it's a bacteria, right? It's a bacteria. Bacteria means prokaryotic or eukaryotic? Prokaryotic. It means we got this streptokinase from a prokaryotic organism. We got streptokinase from a prokaryotic organism. Sir, this streptokinase is used as what, sir? Clot buster. Used as what? Clot buster. What it does? Removes clots. From where? From blood vessels of myocardial infection patients. It means patients who are suffering with myocardial infections, from the patient's blood vessels, this streptokinase removes the clots. That's why we are calling streptokinase as a clot buster. Who is clot buster? Streptokinase is a clot buster. What it does? Streptokinase removes. What it removes? Removes clots. From where, sir? Removes clots from blood vessels. Blood vessels. Blood vessels of myocardial infection. Myocardial infection patients, which leads to heart attack. Sir, what does this statement mean, sir? If in blood vessels of a myocardial infection patient clots are there, then it leads to heart attack. To prevent heart attack, okay, in a myocardial infection patient, from blood vessels, what should be removed? Clots should be removed. To remove that clot, what we are using? A clot buster. Who is that clot buster, sir? Streptokinase. Therefore, streptokinase is a clot buster. It removes clots from blood vessels of a myocardial infection patient. This myocardial infection, which may lead to what? Heart attack. Myocardial infection may lead to what, sir? Heart attack. To prevent this heart attack, we are removing what? We are removing clots. From where? Blood vessels. By using what? A clot buster. Who acts as clot buster here? Streptokinase acts as a clot buster. Is it okay? Right. Now, what is another name for streptokinase? Another name for streptokinase? Tissue plasminogen activator. What is another name for streptokinase? Streptokinase also called as a tissue plasminogen activator. We can write it in shortcut as a TPA. What TPA stands for? Tissue plasminogen activator. It is another name for streptokinase. Streptokinase acts as clot buster, extracted from Streptococcus bacteria, a prokaryotic organism. Is it okay? Right. Now go for number 2. What it is? Cyclosporin A. Cyclosporin A. Cyclosporin A. This cyclosporin A is extracted. Cyclosporin A is extracted from a microorganism by name Trichoderma polysporum. What is the microorganism name? Trichoderma polysporum. Trichoderma polysporum. Sir, this Trichoderma polysporum, it is a fungi. Sir, Trichoderma polysporum comes under which class, sir? Deuteromycetes. Comes under class what? Deuteromycetes. In first year, we read that the common name of Deuteromycetes, I am speaking about common name of Deuteromycetes, is imperfect fungi, right? What is the common name of Deuteromycetes? Imperfect fungi. Imperfect fungi. Sir, Trichoderma polysporum, it's a fungi. Comes under which class? Deuteromycetes. What is the common name of Deuteromycetes? Imperfect fungi. We are saying that Trichoderma polysporum is a fungi. Fungi means it's prokaryotic or eukaryotic. It's a eukaryotic, right? It is what? Eukaryotic. It is eukaryotic. Sir, from this Trichoderma polysporum, what is obtained? Cyclosporin A is obtained. Cyclosporin A is obtained. Sir, what is the use of this cyclosporin A, sir? This cyclosporin A is used as a immunosuppressive agent. It is used as what, sir? It is used as a immunosuppressive agent. It is used as which agent? Immunosuppressive agent. It means it is suppressing which system? Immune system. Where? In patients who has undergone organ transplantation. Undergone what? Organ transplantation. During organ transplantation process, in the patient body, the immune system is suppressed by giving cyclosporin A injections. Therefore, cyclosporin A is a immunosuppressive agent. It suppresses the immune system. It suppresses the immune system, right, during organ transplantation. Therefore, during organ transplantation, what gets suppressed? Right, that immune system gets suppressed by giving which injections? Cyclosporin A injection. This cyclosporin A is extracted from where? A fungi. What is that fungi name? Trichoderma polysporum. Belongs to which class? Deuteromycetes class. What is the common name of Deuteromycetes? Imperfect fungi. Therefore, cyclosporin A is extracted from a eukaryotic organism. Extracted from a eukaryotic organism. Right? Now go for number 3. We are discussing other bioactive molecules, right? In other bioactive molecules, we completed number 1 streptokinase, number 2 cyclosporin A. Now we are going for third one, number 3. What it is? Statins. Go for statins. These statins are produced, extracted from Monascus. What it is? Monascus purpureus. What it is? What is the microorganism name? Monascus purpureus. Monascus purpureus. Monascus purpureus is a yeast. We know that yeast means unicellular what? Algae or fungi? Unicellular fungi. Therefore, it becomes prokaryotic or eukaryotic, sir. It becomes right, eukaryotic. What it becomes? Eukaryotic. It becomes eukaryotic. Sir, from this Monascus purpureus, what is extracted, sir? From this Monascus purpureus, right, statins are extracted. Statins are obtained. Statins are obtained. Sir, what is the use of these statins, sir? These statins, they are used as a blood cholesterol lowering agents. Therefore, statins acts as a blood cholesterol lowering agents. Blood cholesterol lowering agents. Who is acting as blood cholesterol lowering agents? Statins. From where these statins are extracted? From Monascus purpureus. Who is this Monascus purpureus? It is a yeast, unicellular fungi. Therefore, statins are extracted from a eukaryotic organism. Statins acts as blood cholesterol lowering agents. What does it mean? It means statins, they reduces the cholesterol level in the blood. Statins reduces the cholesterol level in the blood. Who is reducing cholesterol level in the blood? Statins. Sir, how a statin reduces a cholesterol level in the blood, sir? How statins reduces cholesterol level in the blood? Listen. To understand this concept, first you should know how cholesterol is synthesized. How cholesterol is synthesized. Mevalonate. This is a substance. Mevalonate. Sir, this mevalonate, right, it synthesizes cholesterol. Who is synthesizing cholesterol? Mevalonate. So, can I call this mevalonate as a substrate? Yes. Therefore, in this chemical reaction, who is a substrate, sir? Mevalonate is a substrate. Who is a product, sir? Cholesterol. Cholesterol is a product. Is it okay? This reaction is catalyzed by one enzyme. This reaction is catalyzed, takes place in presence of an enzyme by name beta hydroxy. What is the enzyme name? Beta hydroxy, beta methyl, beta hydroxy, beta methyl glutaryl What it is? Glutaryl CoA reductase. This is a single enzyme name. Here two enzymes are not there. This is the name of a single enzyme. What is the enzyme name? Beta hydroxy, beta hydroxy, beta methyl, glutaryl, right? CoA reductase. I already told you CoA means coenzyme A, right? Sir, what is the shortcut of this enzyme, sir? Beta hydroxy, right? Beta methyl, right? Glutaryl coenzyme A reductase. This is the shortcut of the enzyme. There is beta hydroxy, beta methyl, glutaryl coenzyme A reductase. Now see this reaction once. What is the substrate in this reaction? Mevalonate. What is the substrate in this reaction? Mevalonate. What is the product? Cholesterol. Who is catalyzing this reaction? It takes place in presence of which enzyme? This reaction takes place in presence of which enzyme? Beta hydroxy, beta methyl, glutaryl CoA reductase. Yes or no? Now listen this statement carefully. To produce cholesterol, mevalonate is required. Yes or no? To produce cholesterol, this enzyme is required, right? Enzyme is required. Now see here. I am drawing the enzyme. Now listen here. This is right, beta hydroxy, beta methyl, glutaryl coenzyme A reductase enzyme. Reductase enzyme. Is it okay? Right. Each and every enzyme contains one specific site. Not only this enzyme, you take any enzyme. Each and every enzyme contains one specific site. That specific site is called as a active site. What is that specific site called as a active site? That specific site is called as active site. Is it okay? Right. Now, what is the substrate in this reaction, sir? Mevalonate. This mevalonate, what it is? Substrate. Comes and binds in the active site of this enzyme. Who binds? Mevalonate. What it is? Substrate, where it binds in the active site of what? Enzyme. Once mevalonate binds in the active site of this enzyme, this mevalonate undergoes chemical changes. Who undergoes chemical changes? Mevalonate undergoes chemical changes. When? Once it comes and binds in the active site of this enzyme. Due to that chemical changes, mevalonate changes into cholesterol. What changes into what, sir? Mevalonate changes into cholesterol. Is it okay? Right. Therefore, sir, to convert mevalonate into cholesterol, right, mevalonate should bind in the active site of this enzyme. Yes or no? For this conversion, right, it means to convert mevalonate into cholesterol, the mevalonate has to bind where? In the active site of this enzyme. Should bind in the active site of the enzyme. Yes or no? Right. Now listen here. What is that substrate name? Mevalonate. Mevalonate. What it is? Substrate. Now these statements are important. You should listen carefully, right? This mevalonate, what it is? Substrate. It should bind in the active site of this enzyme. Yes or no? Right. Now take statins. What they are? Statins. Sir, these statins, they are structurally similar to mevalonate. Statins, they are structurally similar to what? Mevalonate. Therefore, statins resembles mevalonate. Statins resembles what, sir? Mevalonate. So what happens? instead of mevalonate, statins goes and binds in the active site of this enzyme. Instead of what? Instead of mevalonate, instead of what, sir? Mevalonate, what goes and binds in the active site of this enzyme? Statins goes and binds in the active site of this enzyme. Once statins binds in the active site of this enzyme gets inhibited. What gets inhibited? Beta hydroxy, beta methyl glutaryl coenzyme A reductase enzyme gets inhibited. Who is inhibiting this enzyme? Statin. Sir, how it is inhibiting, sir? It is competing with mevalonate. Who is competing with mevalonate? Statin. Who is competing with mevalonate? Statin. For example, there is one sofa. 2 students are there. Out of 2, only one can sit. Yes or no? It means the 2 students, they are competing for one chair, for one sofa. Similarly, right, there is only one active site. Only one can bind. Instead of mevalonate, here who is binding, sir? Statins are binding. Right. For this binding, what happens means the statins compete with mevalonate. What competes with what? Statins compete with mevalonate. Therefore, statins becomes what, sir? Competitive inhibitor. Competitive inhibitor. Who is the competitive inhibitor here? Who is the competitive inhibitor here? Statins. Okay. Therefore, statins competes with mevalonate. Statins compete with mevalonate. Statins goes and binds in the active site of this enzyme. So, enzyme gets inhibited. Therefore, statins are competitive inhibitors of this enzyme. Statins are competitive inhibitors of this enzyme. Once this enzyme gets inhibited, mevalonate cannot be converted into cholesterol. What cannot be converted into what? Mevalonate cannot be converted into cholesterol. Therefore, synthesis of cholesterol decreases. What decreases? Synthesis of cholesterol decreases. Who decreased the synthesis of cholesterol? Statin. How, sir? By binding in the active site of this enzyme, by which the enzyme gets inhibited. So, statins acts as a blood cholesterol lowering agents. What acts as blood cholesterol lowering agent? Statins acts as a blood cholesterol lowering agents. This statement is very, very important. Listen carefully. Statins competes with mevalonate to bind in the active site, of beta hydroxy, beta methyl glutaryl coenzyme A reductase. Yes or no? Right? Once statin binds in the active site of enzyme, once statin binds in the active site of what? Enzyme. The enzyme is competitively inhibited. What gets inhibited? The enzyme is competitively inhibited. As a enzyme is inhibited, what is inhibited? As enzyme is inhibited, right, the synthesis of cholesterol, what happens? Decreases. Synthesis of cholesterol decreases. So we are calling statins as blood cholesterol lowering agents. This is concerned to other bioactive molecules. Thank you.